Okay, rate of change part 4. We continue. We ended up to, here. It will be 225 over 40 pi h square. 225 over 40 pi h square, right? I can simplify it. I can divide by 5. It will be 225 divided by 5. It will be 45, right? 45 over 8 pi r square. Part B of this example. Now we found the h to dt at any time. The h to dt increase of height of water, depth of water at any time, it's 45 over 8 pi r square. So it depends on the radius, right? This is the depth of water, okay? Depth of water, that's what we need to find from the beginning, d of h. Now, in part B, he says, evaluate the rate obtained in part A, which is dh over dt, which is equal to 45 over 8 pi r square, when the height of water is 5 centimeter, h equal 5 centimeter, and then when the height is 9 centimeter. If h is 5 centimeter, so what is the h over dt in this case? It's equal to 225 over 40 pi times 25, because h square, right? We divide by 25 in the numerator and denominator. We get an answer 9 over 40 pi. This is the change of height at when the radius is 5 centimeters, right? It's 9 over 40 pi centimeter because it's height, per second because it's per time. Now for h equal 9 centimeter, same thing. We just need to replace, instead of h this time, 9 centimeter. So it's 225 over 40 pi radius square. So it's 81. The answer, after we simplify it, it will be dh over dt equal, we will find the answer. We simplify 225 and 81, both divisible by 9. This will be 5, and this will be 81 will be 9 times 40, right? 9 times 40. 81 divided by 9. 225 divided by 9, it's not 5. Divided by 9, it will be 25, right? 25 over 40 pi times 9. We can divide by 5 now. It's 5 over 8, right? Pi times 9. So the final answer is 5 over 72 pi. Also, it's in centimeter per second square. Per second, sorry. Now part B, part C. Part C, what do we have? Now he's telling me that find the rate at which the surface area of water is increasing at any time. Surface area of water increasing. So we should find the derivative of what? Of area of water, right? To the, at any time, right? At any time to t. How much is dA over dt? Again, the surface area of water, as you can see, is circular. The surface area of water is circular. So I'm finding the area of a circle. What is the area of a circle? The area of a circle is equal to pi r square. And if we derive this area to dr, we're getting 2 pi r, right? Which is the circumference of the circle. So the circumference of the circle is the derivative of the area in with respect to r, in terms of r. Okay, that's good. Chain rule says what? dA over dt is equal to dA over dr, we found it, times dr over dt. So I can tell him that dA over dt is 2 pi r, again times dr to dt, derivative of radius with respect to time, right? Now, as you can remember up, we found the radius in terms of, we found r in terms of h, right? we found R in terms of H. I guess we got this one here. R is 2 over 15H, right? We go here and we tell him that R, we found it as 2 over 15H. This implies we can find H in terms of R, which is 15 divided by 2R, because we need this, right? Now, volume of cylinder is again 1 over 3 pi r squared times H, which is equal 1 over 3 pi r squared times H, which we found it in terms of R, which is 15 divided by 2R. So we end up with 5 over, we simplify it, we get 5 over 2, right? 5 over 2, 15 divided by 3 is 5, and 3 divided by 3 cancel, pi r cube. If we derive both sides of dv to dr, it will be derivative of 5 over 2 pi r cube. It's 3 times 5 over 2. It's 15 over 2 pi r square. This is dv over dr. Derivative of the volume to the radius, right? Let's do a chain rule here again. dv to dt is equal to dv to dr. I just found it, times dr dt. dv over dt, we have it from the beginning of this exercise. It's given as 0.1, right? It's 0.1 centimeter per second cube. dv dr, I just found it as 15 over 2 pi r squared. Now I need to find dr to dt. What is dr to dt? dr to dt, it will be equal 0.1 over all this, right? Over 15 over 2 pi r squared. I will try to make this a little bit easier, faster. 2 times 0.1, it's 0.2 over 15 pi r squared. If we want to multiply by 10, or we can leave it like that, right? What is that? 0.2 over pi r squared. This is dr to dt. This is dr to dt, right? It's dr to dt, and we need it to find, it's dr to dt. If we go back, why I did that? To find dr to dt, because I needed to find the a to dt. We need the a to dr, and we have it. We found it here, and we just found dr to dt. Now I just substitute, right? And just substitute to find the a to dt. Okay, the a to dt, again, it's the a dr, the a to dt, it's equal the a to dr times dr to dt. The ADR, we found it as 2 pi r. I just found the RDT, which is 0.2 over 15 pi r squared. Simplify pi and r. The final answer will be 0.4 over 15 r. And this is at any time. It's derivation of area at any time. Derivation of area of the water poured in this cone. If he continues asking, calculate this rate when the water height, the height of water, which is small h, is 5 centimeter, and then it is 10 centimeter. We do what? We just substitute. This implies dA to dt change in area according to the height. It will be equal to 0.4, right? Is 0.4 according to height of water. According to height of water. So I have to change it again, right? I have to change the r again to r. What do we have it in terms of height? R is 2 over 15 times height, right? So instead of r, I have to change again 15, 2 over 15 we said, right? Times h, 2 over 15 times h, 15 cancel. It's 0.4 over 0.3, 0.4 over 0 over 2 h, right? It's 0.4 divided by 2h, right? And we just substitute instead of h its value, which is 5